Hello and welcome everybody to today's second day of our e-conference on storage technologies. Very pleased to welcome you again. In today's program, we will start with a showcase from our partner SustainSolar with John Fadiran and Gracia Munganga. They will be presenting about containerized storage systems, which are especially suitable for remote locations. This session will be followed by a panel discussion moderated by Avesh Padayashi from SAESA and with three speakers who are all coming from different sectors of the CNI storage space. And so they will all be sharing their insights on what they are seeing in the market currently. And finally, we will close with another showcase, this one focused on lead-acid batteries and tubular gel batteries with our partner Eastman Global and presenter Ashish Saxena, who will be joining us from India. So without further ado, I would like to quickly introduce John Fadiran to you. John is calling us from Cape Town today. He is the project engineer at SustainSolar. He brings in 10 years experience in engineering. He's previously worked with Converge Consulting, is also at the University of Cape Town as a research associate and other companies such as OST Energy and MTN. At SustainSolar, he's responsible for system design, component configuration, commissioning, and also maintenance of the different solutions that SustainSolar provides. And because this is not enough, John is also currently enrolled as a PhD candidate next to his job as SustainSolar. So quite a busy schedule. Very happy that you are able to join us, John, today. And without further ado, I'm happy to invite you together with Gracia. I invite you to turn on your cameras, unmute yourselves, and you may start with your presentation for today.
Good morning, everyone. I hope you can hear me well. So this is my colleague, John. Thank you very much to the AFCIA team for putting together this really good program. I think energy storage is very relevant, and as SustainSolar, we are quite honored to have this platform. Let me share my screen, and hopefully everyone can see.
Yes, this is good.
Full screen mode. Is
Perfect.
That fine? Perfect. Awesome. Right. So as John mentioned, my name is Gracia, and I work for SustainSolar. So SustainSolar is one of the companies under the Sustainable Energy Group of companies. I'll expand on that later. How we structured our presentation is it's in 4 parts. I'll give a bit of background to the Sustainable Energy Group as a group of companies. I'll speak about our track record as SustainSolar, a snapshot of our understanding and the opportunities around battery energy storage from our perspective. And then I'll hand over to John, who's the senior electrical engineer, and he will take you through our product range. So Sustainable Energy Group, or Sustain Group, as we call it, we integrate complex clean energy technologies in containers and essentially ensuring turnkey delivery, but also offering operation and maintenance to our clients. We've got 4 different brands. So under Sustain Power, there's 2 different, let's say, product range. The first one is containerized landfill gas, CHPs for landfill gas and biogas. And in response really to some of the load shedding challenges that South Africa is currently experiencing, we've also put together containerized gas standby generators and also a solution for peak shaving to displace really a lot of the diesel generators that were being proliferated in South Africa. SustainSolar targets off-grid and hybrid solutions, and the latest addition to our sort of brands is Sustain Storage, which we will expand on later on. Let me just see, next slide. So our leadership team combines 60 plus years of experience across manufacturing and the power sector, both in Europe and in Africa. And we've got a solid team of engineers that really support
All right. As introduced earlier, I am an engineer, design engineer, and here to just run through our product range. As noted by Gracia, we have sort of like differentiated our low voltage and a high voltage product range. And that's because this is a talk about CNI applications, and what we found to fit the CNI range is as a storage capacity of from 150 kilowatt hours to around 2 megawatt hours. And we've designed our products that fit into this range from both low voltage to high voltage. Now, I think the application when we talk of CNI is easily described as backup, peak shaving, clean power, and maybe self-consumption. The low voltage being defined here is 48 to 52 volts, and the high voltage being defined here is 50 volts on the battery DC side. Now, while we have worked with many inverters, we just like to make note of our local, easily supplied product, which is SMA inverters and the solar MD batteries. These have been found to work very durable, and I will dive into that later as to why we found them very durable when it comes to running a technical due diligence on selecting a battery energy storage solution. Furthermore, the transition from low voltage to high voltage, I think, has been very natural for us, using the likes of test inverters and SunGrow inverters and solar MD batteries. We found that they have a higher energy density, they have a higher number of cycles on the battery modules, and as a result, you have a better cost per kilowatt hour. Having put that into a picture, I think the pictogram, I mean, the images just show you what we do in terms of modeling the system for you. We will talk about what goes into a container solution, the design of it, the implementation of it, and putting it together. What we are just going to go on to next is just to give me a second. Okay, the next slide is just about the battery selection. So you have an idea that you need a battery energy storage solution. And what we define and what we understand or bring to the market is that a battery energy storage manufacturer should offer you a detailed selection process, which doubles up as a self-guide and a due diligence before you make an investment. Understanding that the battery of energy storage is very expensive, although it is improving, it is an investment. Now, what we help you and we guide you through is that you have a clear understanding of the applications that a BESS offers you. And that ranges from self-consumption optimization. What we found in the industry is a lot of CNI projects have loss of PV generation over the weekend. A battery energy storage comes into play to actually help you store up some energy on the weekend and make use of it. For example, on a Monday or over the weekend, and save up some of your lost PV generation. You have physical peak shaving as well. If you have an applied limit in terms of capacity to your utility, your peak shaving becomes very usable. Energy focused. This might not be very familiar with you, but for some instances, should you have weather predictions, we have the capacity to integrate energy focus into your battery storage systems. The last two items are services such as ancillary services, which could be frequency regulation and hybrid diesel optimization. Having understanding the potential applications you could have with your BESS, we now want you to understand the integration. The integration on site would range from the point of connection, to which could be low voltage or high or medium voltage, the environmental conditions in which the BESS would sit. This is your humidity and your temperatures. If you do not have access to this data, we would work with it to make sure you have this data before you place your BESS in such a setting. We'll dive a little bit more into how that is very critical in the life of a battery storage system. In terms of contingencies and black start, we help you understand, haven't integrated your BESS. We help you understand the contingencies in terms of a shutdown and how to restart the system. This has to be well understood by yourself, especially when you're looking at battery storage in the megawatt range. Lastly, we would, as a due diligence, help you understand what cell chemistry you have in terms of options the applicable C rate, that is whether you can deplete your battery in an hour or half an hour, or at worst case, 2 hours. And in terms of grid requirement, which is often tied to the technology selection, we would run you through your inverted choices as to what inverted choices do you have and how they apply to your grid code and grid requirement. And lastly, what's very important, which we find very useful, is your operations and management. You have local services that will help you maintain your system. Having said, do bear in mind your BESS is a very great investment. The next slide, the next slide just goes to say, defining your product and why you would choose a container. You would choose a container because it's a turnkey product that's delivered factory tested. So the system is fully tested over multiple cycles before it's delivered to sites, which means all the testing that you would have done on site is conducted in a factory. Secondly, having used a shipping container, it puts your battery in a temperature-controlled environment. And you all are very familiar with the lifetime of your battery is very dependent on what temperatures you operate. Now, putting in a container, a fully insulated container, I'll show you a few more images later, helps you and gives you a chance to ensure the lifetime of your battery storage. And lastly, the system should be augmented with fire detection and fire suppression. What I like to say is without all this in place, you do not have a battery energy storage system. You have a solution, but not a system that's designed to protect itself. And part of the project implementation is using the container as opposed to using a brick and mortar building or just any space within the setting, is that you reduce some risks and you reduce the commissioning timeline. You might find it strange to understand how you reduce some risks, but what that happens is, should you need to claim warranty on your product, having put your product in a 20 or a 40-foot container helps you monitor the temperature and the environment of the equipment. Should you need to claim warranty 10 years or 5 years down the line, you have a good record of how your battery is operated. Having made an investment of $100,000 to $500,000, you don't want to lose that investment in 3 years down the line, which is why we've paid some emphasis onto the product definition, the product implementation, and the operational life. So the next slide just goes on to say, having understood and defined the applications that you require, what do you need to look for in a BESS? And we like to say, if you've ever tried to claim warranty on a product that no longer exists, or worse yet, a company that no longer exists, the question is, how do you go about that? Maybe there's nothing you can do. So the best you can do is, at the time of implementation, you should use a container that would help you de-risk your project life. Now, what that means is using a container will help you protect your asset. If 5 years down the line, you need to claim warranty from a company that no longer exists, you know that you've operated in the best suitable conditions. Now, your product definition is incomplete if you do not understand the number of cycles your battery operates. Never put money on a battery if you don't understand the number of cycles. Secondly, if you do not understand the operational expenses of your battery system. If you do not understand how to replace a module, the product is not complete. And last but not the least, the battery state of health indicator. It is very important that you understand what is the indicator of the state of health. That means if you were to procure a 1 megawatt 3 years down the line over a cycle, you no longer get a megawatt hour out of it, but you get, for example, 800 kilowatt hours out of the same battery unit. Now, the degradation over the period is what you need to model into the operation of your system. Now, verification of the application. You do not have a product if your BESS manufacturer has not confirmed the application with you, commissioning timeline, and the asset location or potential relocation. So using a container helps know that should you need to relocate your assets, it's very easily relocatable. Should it be financed or you provide that to your client on a PPA, you know that using a shipping container makes it easy to relocate. I'm just going to slide through one of the main products that how we help you attack this requirement. As SustainSolar will help you through understanding the cost per kilowatt hour and the throughput, integrate the PV operational expenses, understanding the inverters, the workmanship that go into place. We will work with a third-party EMS to make sure that the container is built into structure. Lastly, what I will just mention is what we define as a singular application track. Many users would buy a BESS without knowing that for the same cost that you would pay for your energy management system, you could get multiple applications out of the same cost. So do not be caught in a singular application trap. Now I'm just going to run through some of our product lines to give you a good slight image of what we have designed in terms of low voltage and high voltage solutions. Okay, what we have here is our low voltage product, which is designed in a 40-foot container. You could just pay attention to the ventilation and temperature control that's being inflated in the container with fire suppression. This is built around SMA inverters and solar MD batteries, and they offer a very good cycle rate. We have options of 4,000 cycles to 6,000 cycles, which is industry standard at 25 degrees Celsius. This is one of the solutions that we've put into the market. Subsequent to that, we have a high voltage solution, which is built around either SunGrow or a test. And this can be built in also 20 or 40-foot containers with a hybrid or a power control system of up to 500 kilowatt hours. What we find useful is definition of the C rate and the application and the depth of discharge. As noted in our designs, you will note that we've implemented fire suppression, fire detection. And what we have a good experience is helping you run through your technical due diligence, such that having designed a product based on the requirement that we stipulated. As you will recall, I mentioned that your BESS is not complete until you go through those definitions, such that 5 years down the line, we've put in the right technical requirements in the container design to ensure the life cycle of the battery. That being said, I think you're more than welcome to reach out to us if you want to find out more about the product lines and how to integrate a solution to meet your application. Thank you very much for the time.
I think if you scroll to the last slide, then there's a few people that have asked for our contact details. So it is in the slide pack. When you receive that, you would be able to contact us. Thank you very much, John, and thank you to the AFCIA team as well for this opportunity. And we look forward to engaging with you. Yeah.
Well, thank you very much to both of you. I have two, unfortunately, I had to choose only two very quick questions for you. First question from Leopold. In your solutions, how long is the energy actually being stored for? Is it 1 day, 1 week, 1 month, 1 year, maybe?
So most of the energies on our systems are designed for a 1-day contingency, which means you have an autonomy of 1 day, which means it's usually designed around PV systems. So over a 24-hour period, your battery depletes to approximately a 10% depth of discharge. We have found many medical applications where you have a need for a 2-day autonomy, but those are usually mobile clinics and co.
Yes, and then I assume it's just a question of having a bigger size of storage depending on the specific load.
Correct.
And then the second question I would like to submit to you is a question from Ahos and Pierre. Interesting question. We've never had such a question before. Are your solutions suitable for Francophone African countries where the voltage is 230 to 410 volts?
Yes, they are suitable. The inverters that we use have quite a wide voltage range. And what we do very well is before we ship the equipment to site, we test it at the required voltage, and we actually share such factory acceptance testing with you.
All right. Well, I think this is very clear. Thank you very much to both of you.